So let me get rid of this news stuff. And all right, so here we are. This is CNET 121. Now the ad period. Today is the 30th of January. The ad period ends on Friday. So if you're trying to add a class, make a request in the next couple of days. After that, it'll be a late add, which is possible, but it's more hassle. So we're here. The first couple of classes have gone by. We're up to Mod 3. And all right. I thought I already did. I already did ED32 and F200. I'm going to do F201 or something. My demos are a little ahead. That's fine. All right. So let's take a look at Mod 3, which is on one of these tabs up here. There. All right. So this is hardware. So SCSI is a protocol. I don't see it much anymore, but it's a way to connect hard drives and other things to your computer. And therefore, if they are, you need to connect it with these SCSI cables and suck the data off if you want to get it off of them. IDE is another one that's pretty old. This one here with the parallel rows of pins. I haven't seen this in use in many years, but I mean, old machines might have it to connect with a hard drive. What everybody has now is SATA. This is what you typically see, this red one with a little L-shaped connector, serial ATA, to connect hard drives and CD-ROMs and other things. Anyway, that's why you have to have various write protectors for these different connectors so you can image drives with each of these in a forensic lab. So you clone a hard disk. You want to, now a clone is an exact copy of the hard drive, so you have a 500 gig drive and you make another 500 gig drive with exactly the same data. And then you could boot from it, and that's used as backup. What forensic people do is typically not that kind of clone, that they make an image, which is a file that contains all the data from the drive, but typically compressed, like an E01 image. And it's a bit-for-bit copy, but you can't boot from an image. It's not laid out on the disk in exactly the same sector and track as the original one, but it contains all the data for purposes of forensic examination. So you can clone a drive, and there are devices you can buy that will just plug in one drive, plug in another drive, and press the button to clone it, because this is very common for tech support and to deploy on operating systems at companies. You get one drive with Windows and all your apps on it, and then you just clone it and swap out the drives. Most companies don't bother to fix any problems on the endpoint devices. If you get it infected or it's not working, they just replace the hard drive with a working hard drive, and off you go. All right. And SSDs are, of course, very common on almost everything's using them now, except these heavy desktop machines, like cell phones and portable devices like my MacBook here. So it's using flash memory, and typically, I mentioned before, garbage collection runs in the background, so you usually cannot recover any deleted files from a hard drive. When you delete it, within a few seconds, the garbage collection process comes by and really erases it, so that very usually nothing or only very little of that file is left. They lose less power, and that's why people prefer them on cell phones and such, and they're lighter. They're more expensive, though. I say, recovering deleted files is more challenging. That's one word for it. It's effectively impossible, unless you have an unusual situation where the garbage collection is not working because you put in an off-brand SSD or you don't have quite the right driver or something. But if all your stuff is up to date, the garbage collection should mostly erase it all. That does, by the way, mean that if you take an image of an SSD and calculate a hash, and then take an image again, you won't get the same answer, because while nothing is happening, garbage collection is going on. So it is changing the content. So that's the thing to be aware of. Right. And trim. Trim is the operating system function that informs the SSD when a file is deleted. See, a magnetic hard drive does not know when you delete a file. It has it has the master file table, which has the metadata, and it has the file sectors. When you delete a file, you just send a write command to write data into the master file table, marking those sectors available, which tells the operating system that that file has been deleted, but the hard drive does not know that. The hard drive does not know the NTFS format, does not know any of this. It just knows what sector has data in. The hard drive is stupid. It just reads and writes sectors. But SSDs are smart. They do know what a file is, and they do know when a file is deleted if you have the trim function running, which is an OS function that informs the SSD which blocks are no longer in use. All right, anyway, all right, then there's RAM, of course, on these chips. RAM is what is main memory. It's fast, much faster than the hard drive or SSD, so it's where you store temporary information while you're working. But when you turn off the power, it forgets within a few seconds. If you cool it, it can preserve the memory for perhaps 30 minutes, and there are attacks where you freeze the RAM and take it out and put it in another machine to steal the data off a machine, but that's a bit extravagant. Volatility is the main tool to analyze a RAM image. You copy the RAM into a file, and volatility will parse that into notepad files and browser documents and so on, looking for marks in there and putting together the images of what you were doing in RAM. A fun fact, by the way, about Macs is Mac RAM is compressed, which is a pretty smart idea, and I'm surprised PCs don't do it yet. So you can get more good out of the RAM, and they keep changing it in different versions. That's why there are no free tools like Volatility that work for the Mac, and any that do work are from many generations back. You have to pay a lot of money to get Mac forensic tools that work because they keep changing everything on the Mac, and the open source people can't keep up. Then there are RAID arrays. If you are a company, you typically don't want to have just one hard drive, so when it fails, you're down. You set up a RAID array like this, where you have multiple drives, and it doesn't need all of them to work. It can have one or two of these fail and still work, and so it'll turn on a red light and say, this drive has failed, replace it with another, and in the meantime, it continues to operate, although more slowly, with the data on the remaining drives, because it's storing extra copies of the data in stripes in various patterns there. That's very common. By the way, when I talk to the people at DriveSavers, they say the whole point of a RAID array is not all the drives will fail at once. Now, you probably bought them all at the same time. They're the same model, and you ran them at the same time. But you imagine that they're dying as a random act. And what they said at DriveSavers is, it's not. They say very often the cloud storage companies that you're using to back up your stuff are coming to us with their array with 20 drives, where many drives failed all at once and now they're hosed. Because apparently it is not true that they fail randomly. It's probably more true that they fail because of power surges or something that affected them all. And so more often than you would think, than simple-minded statistics would predict, this thing will fail. Anyway, FireWire, before USB 2, there was FireWire, which a lot of people liked. It's somewhat faster than USB 2. I think these days that we have USB-C, again, it doesn't matter that much. And you got flash drives, those thumb drives. You don't see those around anymore so much, but for a long time they were really popular, and they're typically fat. You typically don't want them to be formatted with NTFS because then there would be an owner. When you move it to another machine, you wouldn't be the owner. So you wouldn't be able to read or write the files, so that kind of defeats the whole point. FAT or exFAT, if you're talking to Macs, is what you usually use. And then external, if you have an NTFS formatted thumb drive, then when you save a file, it will know your owner, and your owner will be the login account on that Windows machine. When you put it in a different Windows machine, you won't be the same person, so you won't be able to read the files. I've had this happen to me. You have to go in and share it with everyone first to accomplish what you typically want on a thumb drive. That's why formatting it with FAT is better, because FAT has no permissions. Physical access to the drive means you can read and write everything.
So you format the NTFS to like a password on it or something?
It's not a password, but in NTFS, everything has to have an owner. NTFS, every file has an owner, and that owner has full control. And if you don't share full control to everyone, other people don't have full control. So when you take it to another drive, you might not be able to read or write it. I've had it happen. It's annoying. That's why people usually do not use NTFS on these drives.
When you format it, NTFS, do you have to format differently?
Yes. It's a different layout. So you have to reformat the thumb drive. Yeah, either FAT or exFAT or NTFS are typically what you use.
So when you format it, NTFS, you don't have to do anything special, just do format.
No, you don't. But when you save a file, it will save with your current ownership information. And by default, it won't be shared with other people. So if you then carry it to a different machine, it won't let you read it. That's the problem. Anyway, all right, so external hard drives just have a USB hard drive or SATA or something inside here with a cable. That's another way to do it. And then it'll have external power, which is nice. You can encrypt any of these external devices like thumb drives and removable hard drives, which you might want to do if you're using them for backup. BitLocker will do that. Other things like TrueCrypt can do it too. And then there's these other cards out here, multimedia cards and SD cards and so on. They're all just sort of like floppies. You can use them in cameras and such, and they can move moderate amounts of data around. Compact flash cards, all these things, very similar things. You just have to have the right brand and the model to connect them, and they all read and write about the same way.
No zip disks?
Zip disks seem to be extinct, but they're another version of the same thing, sure. Yeah. Anyway, all right, and so some people get special readers just to read all these things with a whole bunch of connect all of them sort of thing you might do. If you're a forensic examiner, read as much as possible. Like I say, there's so many computer technologies, often you get something and you don't have the ability to read it. Sometimes people have to go to like users groups to find people with like an Amiga or something to read this weird thing they find lying around. Police do. Then of course compact discs, these optical storage. I don't see this that much anymore either, but CDs stored data, and then there was DVDs, and then there's Blu-ray in principle. And you know, the main thing about them is the read-only ones are the ones that last forever. They're stamped at the factory and can't be changed, but those aren't very interesting because what's on there is typically something like a movie, not anything personal. What you want is the rewritable ones that have personal data on them, and then it can be anything in principle. Just I don't think they're that common anymore. And floppies, of course, so you might have these things around. And zip disks, or you have these things. All these things exist in principle, but I don't think anybody would have any of these things on a modern system. Probably not even optical drives. And mag tapes are still used. They're the cheapest way to back up a large amount of data. A little cassette of mag tape. They've used it at companies I've had. So it's an option, although more and more people just back up stuff in the cloud, which is convenient but more expensive. And requires a fast internet connection if you're backing up a lot of data. So anyway, let's take a look at a Kahoot. It's mod 3, so it's here. And I'll take a look and see if there are comments. No new ones? Okay. So the Kahoot should be somewhere. Let's see. Thought I started it. Where is it? This one? Oh, here we go. All right. Are you in? Okay, let's give it a shot. All right, what's the most common hard drive connector? SATA these days, all right. All right, so what process makes a single file containing all the data on your evidence hard drive? Image. Now the difference between an image and a backup or a copy is that the image contains every bit stored on the drive, including the deleted files. Backup or copy only copy the active data. All right. All right. Which storage device erases the old data automatically? SSDs. The most common one we're All right, and what storage device do you read with a laser? That's a DVD. Good. I think our D2 has one before, but I don't think we know the real name. I don't think we know that person's real name either. Anyway, if you want your points, you'll have to tell us your real name. All right, let me stop this recording.